Okay, dear students, in the last class we have finished 5.3 exercise. 5.3 exercise questions all we have completed. Those were derivatives of implicit functions and inverse trigonometric functions. Okay, inverted trigonometric functions, the implicit functions, all we have done. Okay, now you see, before going to 5.4 exercise, these 5.4 concepts are we can say not derivatives, um, logarithmic and exponential functions. Exponential and logarithmic functions. Okay. For exponential and logarithmic functions, standard derivatives, two derivatives are there. For exponential one and logarithm one. But for this derivatives, proof is not required. That means proof they are not given and they don't ask also in examination. Simply we will take, but we will get explanation. Okay. You see, d by dx of e power x is equal to e power x. This is exponential function. We will come afterwards. This okay, what is e and all. See, without this also we have done already. If e is not there, something power x square, x cube or something is there means we have done already. Okay, that is why. But 10 power x we have not done until now. Okay, here also e is a constant, like 10 power x means 10 power x, e power x both are same, like we can treat it. What will come now? 10 power x means 10 power x only will come, you see here. Okay, this is a exponential function. Okay, now you see here d by dx of logarithmic function also we will see, comma d by dx of log x is equal to 1 by x. Only these two derivatives, standards, you can note down. Why? Because already 14 we have noted down earlier. These two also you can include. Total it will become 16 derivatives, like okay, standard derivatives. With these two derivatives only we are going to do entire this 5.4 exercise, but not in this class. Next class we will do. This class we will understand what are logarithmic exponential function and logarithmic function. We will understand completely. Why? Because exponential, logarithm and all, I think first time you are getting in NCERT. That is why. Okay. Just again I will write down this before closing the class, these two. But you have to note down, that's all. These proof are not required. But we will understand it clearly what are logarithmic and exponential functions. First of all, let me tell about exponential function. Okay, I am writing again exponential function. Exponential function. See, I am not writing derivatives of exponential function or like. Why? Because first of all, we are understanding exponential function. Afterwards, we will understand logarithmic function. Then finally, what I have written, those two, just I will write those two derivatives. Okay? Okay. What is exponential function? If you give input, tremendous output comes continuously. If you change, or else we can say in this in another way. If we change input slowly but tremendously, if output is changes, that is called exponential. In positive side. In positive side means positive side has to come means input also you have to restrict it. And the conditions, some conditions you have to keep. Okay, those conditions we will see afterwards. But let me show you what is a tremendously increment or not. Okay, you see here what I am writing. Say f of x is equal to x. Okay, that means here x power 1 is there. Okay, if you give 1, what will come? 1. If you give 2, what will come? 2. If you give 3, what will come? 3. If you give 4, what will come? 4. Why? Because f of x is equal to x. That's all. Okay, this is one case. F of x is equal to x square. If I give 1, then 1 will come. 1 square. If I give 2, 4 will come. If I give 3, 9 will come. If I give 4, 16 will come. You see, earlier we have given 1, 2, 3, 4, but 1, 2, 3, 4 has come. Now 1, 2, 3, 4 we have given, but 1, 4, 3, 16 has come. Okay. See, this is case for x square. What if x cube? F of x is equal to 1, 1, 2, 2 cube 8, 3, 3 cube 27, 4, 4 cube 64, 4 4s are 16, 64, 16 4s are 64. You see here how output has increased. This is output. Na? See, input you have given 1, 1 has come. Input you have given 2, 8 has come. Input you have given 3, 27 has come. Output, you see how increasing 1, 8, 27, 64. Tremendously it is increasing. Tremendously. Large basis. Okay, this is one. What about f to the power, f of x is equal to x to the power of 4? 1 if you give 1 only will come. 2 if you give 2 to the power of 4, 64. Why? Because 2 2s are 4, 4 2s are 4 square, 16, 16 square, 256. Is it okay? 2 to the power of 4, 16 I think. 3 to the power of 4, 81. Okay. 1 to the power of 4, 1, 2 to the power of 4, 16, 3 to the power of 4, 81, 3 3s are 9, 9 9s are 81. Okay. What about 4 if you give? 256. 4 4s are 16, 16 16s are 256. Okay. What you have observed now? You tell me. See, for input 1, any function, only output 1 is coming. That you keep in your mind. Okay, that you keep in your mind. For input 1, that means we can say input as domain x and output as y. Why? Because see, we already know that f of x is equal to y. Then I am writing here x, y, x, y, x, y, x, y. Okay? X is domain. Y is range. Domain you are giving, range you are getting. Okay? You see here, for domain 1, all functions are giving same value. Whatever may be the power. We will understand afterwards also what is power and all. But what you have observed, if this power f of x is equal to, say, now x has come, y also we don't take. Say a power b, shall I take b power a temporarily? Or else I will take b power, b power a only we will take. Afterwards I am going to change this as x. Why? Because x we are going to standardize base. That we will tell afterwards. You see here, b is what? Base. That is why I have taken b. A is what? Power. Base and power. What about f of x or y? Shall we call it as value? Output or value? Whatever it may be. Output or value or something like. Y is equal to output or value. Shall we take? Shall we call this? Okay. Base, power. Base is b, power is a. Now you tell me. I have changed the base. Okay. And I have changed the power also. Both have changed. If you observe carefully, you see here. In x, power is 1. But base goes on changed. X is equal to 1, x is equal to 2, x is equal to 3. Like that I have changed. Okay. In second case, you see x square, base is x. I have changed goes on the base. Power is kept same. Power. Okay. But third case, I have changed the base x cube. I have changed goes on the bases here. Okay. See, when you see one individual function, I have changed only base. But I have done in different functions. Na? Here I have changed power also. See, power 1, power 2, power 3, power 4. what we understand here, these functions, I have not yet called these are exponential functions. These functions will give tremendously increased output. Okay, we will see graph also. With graph also we will understand. Okay, we have not yet called these exponential functions. Why? Because some conditions are there to call exponential function. Why? Because base should be greater than 1 we have to write. Okay, now what I am writing, what I have done here, I have kept base same, power same. In each function power same and base I have changed. Okay, now I want to change the power, wants to keep base as same. Okay, you see what I am writing now. Now another function I am writing, you observe carefully. F of x is equal to b power x. See, b may be some constant, like you take. Like, see, earlier also here 2, 1, 3, 4 are constants only. Na? But you are changing the base, that's all. But constant, base if you change, 1 means 1 power 4, 2 means 2 power 4, 3 means 3 power 4. But power is same. Base, you are changing. But here, see, base is same. Base, say you have taken 10, or you have taken 4, or you have taken 3. Base is same, but power goes on change. Okay. Now you write here. What you are going to write? See, unless you know the base, you cannot write. Say b is greater than 1, or else for the sake I have taken b is equal to 2 for this question. Okay. You see, for p is equal to 2, what will be the, if you give 1, that means 2 power 1, 2. Okay. Then what will be the 2? 2 power 2, 4. Okay, what will be the 3? 2 power 3, 8. What will be the 4? If you give 4, 2 power 4, 16. Okay. Even if you keep base same also, if you see change power goes on, then goes on tremendously, value is increasing or not increasing. Or else you see another example, 4. Say b is equal to 3 I have taken now. Okay, this function b is equal to 3. Now I have given 1. 3 means 3 power 1 is 3. Okay. Then 3 power 2. 2 I have given 3 power 2, 9. Okay. Then 3 power 3, 27. 3 power 4, 81. Is it okay? See, even if you keep base same and increase the power, even if you keep power same and increase the base, in both ways, see, I am not telling both are equal. In both ways, we are going to increase tremendously output. That we want to say. Okay? Now, some conditions are there. What we are doing, you see, y is equal to f of x is equal to b power x, where b is greater than 1. If at all this function is there, this function we will call it as exponential function. Now you come to exponential function. Exponential function. See, why this condition? If b is not greater than 1, b is less than 1, then this condition is not going to apply. Tremendously it will come down. Why? Why? Because you see here, less than 1 means, you see, 1 by 2 is there. 1 by 2 power 1 is equal to 1 by 2. 1 by 2 power 2 is equal to 1 by 4. 1 by 4 is less. Even though you have increased power, but that value is going to become less. Okay. 1 by 2 whole power 3 is 1 by 8. 1 by 8 value is feel less than, more less than 1 by 4. That is the logic you have to understand. That is why for calling to eligible an exponential function, exponential means it is increasing tremendously. It is increasing tremendously. It is going to give result tremendously higher output. Small change in input will give higher change in output. You see, 1 you have given, 3 has come. Small, you have given only 1 increased input. Just 2 you have given, but rather than 4 or 5 or 6, it has gone to 9. You have given only 3, but rather than 9, it has gone to 27. Just 2 you have increased 1, but rather than 28 or 29, it has gone to 81. This is called tremendously increment, exponential growth. Okay, exponential growth means this is the exponential growth. For this, what is condition? Base should be greater than 1, b should be greater than 1. You see, f of x is equal to b power x. Like you think, why? Because this analogy is good for understand. B is base, like you will put in your brain, mind, power x. Okay, but here base you are going to fix. But any base. Okay, I am not telling that you have to take b power greater than 1 means b is greater than 1 means you can take 1.5 also, 2 also, whatever it may be. But if you take such that exponential growth will come, that is why this function is going to be called as exponential function. Okay, understand. But now you tell me, for exponential function, shall we give what we can say, domain? Shall we give negative number or not? Is there any condition? See, for exponential function, domain I am writing here. Domain minus infinity to plus infinity r. You can give negative numbers also. Domain. You can give negative numbers also for domain exponential function. Okay. But what will be the range? Range will be positive real number. Range will be positive real number. That means even if you give negative real number also, but positive real number only is going to come. Why? Because already you have made this as a greater than 1 base. You are giving in power only, na? See what I am telling, you understand first carefully. Domain, anything you can give, but real number is output range is real number we are talking about. Okay, just one example I am writing here. Base already greater than 1 means say 2 you have taken base. But domain, if I want to give minus, say minus 3 I am writing. Okay, domain I can give negative also. I have given negative 2 power minus 3. But range, whether it comes negative or not, you see, 2 power minus 3 means 1 power 2 power 3. That means 1 power 8. That is 1.25, 0.125. Positive real number. It may be from 0 to 1, but it is positive only. This is not negative. You understand? How it has happened? Because base you have kept more than 1. You understand now? That means you have already taken care. Base greater than 1 you have kept. That is why even if you give domain negative real number or positive real number, always the range will be positive real numbers only. You understand? What if you give 0? 0 gives also 1 will come, that's all. Something power 0, you see, base is greater than 3 means say 1.5 whole power 0. Something power 0 is 1, that's all, 1 will come. 1 is again positive real number. You understand now? Now do you understand the exponential function? We will go graph, but first you understand the basic concept exponential function. Exponential function means for small change in input or domain, tremendous change in output if comes any function, that function is going to be called as exponential function. Then what is exponential function? F of x or y is equal to b power x is the exponential function provided condition b is greater than 1. Okay, this is exponential function. Then what will be the domain for exponential function? Domain for exponential function is real numbers. Positive, real, negative, both you can give real numbers. Then what will be the range of the exponential function? Range of the exponential function is positive real number only. How it has happened? Even though if you given negative real number, positive real number only output is coming means because we have taken care in the base. Okay, this is the logic you have to understand for exponential function. What we do, we will draw. You see, If it goes on increase the power, tremendously values are going to increase. This you have understand now by practically. Then I am going to draw the graph now. Okay, exponential function. See what are to be taken exponential function. See some standards we have to take exponential function. Those standards also how we have to take and all we will see. Okay, I am going to rub this. See exponential function. Okay. Okay, let me draw some graphs. I will draw for easy understanding. This is x, this is y. You know very well that this side is minus, this side is minus, okay, and this is 0. Okay. See, exponential function already we have told that base should be greater than 1. If it all greater than 1 is there means then negative will not come. Okay, negative numbers. In negative area, the functions are not going to come. Even if you give x power 1 also, straight line will come. Is it okay or not? I am writing this, you see, y is equal to x or f of x is equal to x. Okay. This is first one. Second one I am writing x square. X square means you see this is 1, this is 1, okay, and this is 1. This is y is equal to x square. Why? Because you see, even if you give 1 only will come input 1, output 1 for x square. What about x to the power of 4? Y is equal to x to the power of 4. See, for x to the power of 4 function also, if you give 1 only will come. That means this point you have to keep in mind. 1 1. This is 1 0. This is 0 1. Okay. At 1 all these functions graphs are intersecting. Okay. Okay. See, another function I want to draw this rather than this. What is this function? Y is equal to 10 power x. Base I have kept standardized. Okay, and I have taken 10. Okay. How you see how this graph will come? This I am writing y is equal to 10 power x. Okay. See what I want to say. If it goes on increase the power, the graph is going towards y axis. Okay, and y is equal to 10 power x. This is exponential function only. Why? Because you see y is equal to b power x we have called exponential function. Again I am writing here, you see y is equal to b power x provided b is greater than 1. This is exponential function. Okay, this base I have taken 10. Here we don't know the base. For understanding sake I have written this. Okay, now we will study about only this. Why? Because finally we have to conclude now exponential function graph. 10 power x. 10 power x. Base I have taken greater than 1. Yes. Negative number also shall you give? Yes. Negative number also I have given, you see. This is positive x. This is negative x. X is domain. Input. Even if you give negative number also, see it will never touch 0. Okay. Tremendously greater negative number if you give also. But nearer to 0 it will come. That means this graph y is equal to 10 power x never touches x-axis. Okay. Tremendously greater output it is giving. Yes, definitely it is giving. Why? Because see, if you give 10 power 1, 10. 10 power 2, 100. 10 power 3, 1000. You see, for each input, you see, first 10 times, next 100 times, next 1000 times, like that goes on. Tremendously it is giving increment or growth, exponential growth. That is why y is equal to 10 power x is also exponential function only. Okay. You see, one function y is equal to 10 power x. Okay, we will standardize. Standardizing I am telling. Another function, rather than this much of base, we want to take only one base. What base we will take? That base power x, like 10 power x only we will take, like mathematicians have decided. Okay, they have taken also that number. That number is e. This is called Euler's number. 2.71828, but it is not a, what you can say, irrational number. Irrational number. Continuously it will come. E is equal to 2.7. First of all, I am writing, you see, E is equal to Euler's number. Okay. E is Euler's number. And how it has come? Now see, y is equal to 10 power x, we have standardized 1. Rather than like this much, another one we are standardizing y is equal to e power x. Now, only these two are exponential functions are there. See, this is the condition, y is equal to b power x. Why? Because we are studying these two functions taking some standards. We can say we are going to standardize. See, without these also standard exponential functions are there, provided base should be greater than 1. Base should be greater than 1, y is equal to b power x is an exponential function. But what we study two standardized functions. Standardized exponential functions, I can say. What are these also I will tell afterwards. Y is equal to 10 power x we will study. Y is equal to e power x also we will study. In both cases, base we have standardized. Here base is 10, x is varying. Here base is e, x is varying. Here e means what? 2.71828. How it has come? Okay, you see here. This is called Euler's number. E is equal to 1 by 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial plus, like this goes on continuously. It is there up to infinity. Okay. See, even though after 5, 6, 7, the value is very small. Why? Because you see, e is equal to 1 is okay, 1. 1 by 1 factorial means also 1 only. 1 by 2 factorial means 2 factorial is 2. 2 into 1, 2. 1 by 2 means 0.5. 3 factorial, 1 by 6. Plus 1 by 4 factorial. 4 into 6, 24. Like this, if you goes on add, this number is going to come 2.71828. We will take up to 5 digits. 1, 2, 3, 4, 5. 2.71828. 2.71828. 2.71828. Like that we will understand Euler's number. Okay. You see here 2.5. Already here 2.5 is there. First 3 digits are whatever you can say. First 3 terms. Okay. First 3 terms itself 2.5 has come. Remaining all we have taken like this. Goes on, you can add, but this number also goes. But we need not take up to 2.71828. Like that we will take. This is called Euler's number. Euler's number has come addition of terms. 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus 1 by 4 factorial plus 1 by 5 factorial plus. What is factorial? Factorial we already know. 1 factorial is equal to 1. 2 factorial is equal to 2 into 1. 3 factorial is equal to 3 into 2 into 1. 4 factorial is equal to 4 into 3 into 2 into 1. Okay. Like this will come. That means here 1 will come, 2 will come, 6 will come, 6 into 4, 24 will come. But these are all in denominator, you see, denominator, 1 by. Denominator number is increasing means output is small. If it goes on increase, small value only are going to add. That is why we will take up to 5 digits. 71828. You understand? This is Euler's number. That means these two numbers we have standardized for studying the exponential functions. Okay. Then what are these two functions? Shall we name this? Yes, we can name this. Okay. I am writing. I am naming these two functions. You see, y is equal to 10 power x. If it is there, we will call it as common exponential function. Why? Because these names are important. In logarithms also same are going to come. That is why common logarithm, natural logarithm, like that is why you have to keep remember y is equal to 10 power x. We need not write base is greater than 1, like already base is greater than 1 only. Y is equal to 10 power x. That is why conditions we have already taken care by, I can say comma. Y is equal to 10 power x is a common exponential function. Y is equal to e power x, natural exponential function. You understand now? See, y is equal to 10 power x, y is equal to power x, both graphs are same. Now I can remove this graph, these graphs. Okay? I can remove these graphs. You see, only this graph you can take for both. For both this is same. For both this is same. Same means, see, what we can say. Now 10 power x you need not take. You take only e power x only. Same like. Why? Because it never touches x-axis, but at 1 it is touching. Why? Because x we are giving 0. E power 0 is 1. 10 power 0 is 1. That is the logic you have to understand here. See, these exponential graphs touches y-axis at 1 when you use 0. Okay, that you keep in our mind. Okay, this both you can take as this e power x only. Tremendously it is going to increase. Okay, if base is 10, y is equal to 10 power x, that is called common exponential function. If base is e power x, y is equal to e power x, that function is going to be called as natural exponential function. E value 2.71828. Because greater than 1. Base should be greater than 1. We have told base is greater than 1 only. 2.71828 is greater than 1. Okay, that is why these two are, we are standardized, that's all. Rather than this y is equal to b power x, remaining all, if b is greater than 1, all are going to be called as exponential functions only. Why? Because we will study only about these two. Why? Because in logarithms, common logarithm, natural logarithm is there. And base you have to write, what you have to write and all I will tell afterwards. Okay, these two are 10 and e are standard bases. That is why we have studied. This number, Euler number. How it has come also I will explain to you. Okay, see, exponential functions we have studied even with graph also all. Domain, range, what is e, how it has come, and what to be called, all I have written. Now let us go for logarithmic function. Okay. Let us understand logarithmic functions. Logarithmic functions. You see spelling also. Logarithmic. Logarithmic. Okay. See how we have written y is equal to b power x, comma b is greater than 1, like this function also you can write like this, y is equal to log x. Okay. Standard means, you see, two standards are there. Y is equal to log x to the base e. Y is equal to log x to the base 10. Okay. You have to call log x to the base e, log x to the base 10. Like that you have to call. Log x to the base 10, log x to the base e, log a to the base b. Don't call log b a, that is not correct. Log a to the base b, log x to the base e, log x to the base 10, log x. If nothing written means base e only. That we keep in our mind. In our textbooks, we are talking about textbooks only. We are not talking about outside what is happening under. In our textbook, for examination point of view, log x means log x to the base e. Or else they will mention log x to the base 10 or log x to the base b. Okay, that you keep in your mind. Okay. Now we will understand what is logarithmic function and the relation between our exponential function and this will come. Okay, you see, I am writing, see, something here. Say 2 power 3 is equal to 8. Is it correct? 2 cube is 8. Okay. Now we can write this like this. Log 8 to the base 2 is equal to 3. Vice versa, I am writing here also, you see. Y is equal to log x to the base b. Yes. Then what I am writing here, b power y is equal to x. Okay, first you understand this, then we will see this one. 2 cube is equal to 8. Is it correct? Correct only. Log 8 to the base 2. That means log of value to the base is equal to power. Here 2 is base, 3 is power. Power or index. Okay. Base power value. Okay. Log value to the base is equal to power. You see here, base power value. Log value to the base is equal to power. Here also that is equal to y, you can write here. Like this you can write. See here we can say that here we are going to find power. But you can find anything in this concept. We will understand. Okay, why? Because base change method is also there. This base also you can change. How under? First of all, you understand this. Y is equal to log x. Y is equal to log x, you understand first. B, you write or not write. Base, if you don't write, base will be E. Sorry, exponential, sorry. Euler number. Y is equal to log x, you take. Y you take always this. But here, y is equal to log x, if you write automatically, y will be power. Base will be B. This base will be 10 or E or any other number also. But always base should be greater than 1. Okay. Some conditions. See, there we have seen domain and range for logarithmic, for exponential function. What? Base should be greater than 1. But domain may be both a positive real number, negative real number all there. But logarithmic numbers, I want to write for logarithmic domain greater than 0. That means all positive real numbers only. Not like exponential function. Exponential function domain positive, negative, both real numbers you can give. But here you can give only positive real numbers. Negative real numbers you cannot give. That means what will be the domain here? X. Okay. Then we will talk about base also. Base B. What is base B? For logarithmic function I am talking about. For logarithmic function, base should not be equal to 1. Positive. That means for base 0 to 1 is also there here. For logarithmic function, see, exponential function you should not write base less than 1. Greater than 1. See, for exponential function automatically base is greater than 1 means automatically all positive numbers only, but between 0 to 1 also you should not give. Greater than 1 only you should give. Not domain. Base. See here both cases base and input both are there. Both values you have to consider. For logarithmic function, input you cannot give negative real numbers. In exponential function you have given, but here you cannot give. Vice versa, there base is greater than 1, but here base you can give positive real number but not equal to 1. Why it has also I am telling you. See here. You see here, base you give 2 power 3 is equal to 8. Base if you give 3 power 2 is equal to 9. That means base if you change, power if you change, some values are changing. If you take base 1, 1 power 3 also 1 only, 1 power 4 also 1 only, 1 power 5 also 1 only. That means if you take base 1, this is not going to give any changed result. That is why you cannot find anything. That is why for logarithmic function, base should not be equal to 1. Like that you keep in your mind. And positive real, all positive real numbers you can take. Between 0, 1 and also you can take. But you see, if you take 1 by 2 as base, but domain you are giving always positive number only. That means see base power x only, na? Base power x only. See domain here, if you give positive real number like 4, what is going to happen? 1 by 8. That means what you are understanding here? I will tell afterwards. Okay. First of all, let us understand this. Why? Because negative output comes in logarithm. Logarithm negative output also will come. Domain. Sorry, range. You see here. For logarithmic function, domain I have written greater than 0 means positive real number only. But base should not be equal to 1, but always positive real number. Base. What is range? Range is minus infinity to plus infinity. You understand now? See, with the graph we can understand it easily. First, let us understand this first. Now, do you understand this logarithmic function? Log value to the base is equal to power. Log value to the base is equal to power. You see, this is power, this is base, this is value. Log value to the base is equal to power. Like that you have to understand. Okay. Y is equal to log x means here base will be there b. That b may be 10, or that b may be e, or that b may be anything, but base should not be greater than 1, greater than 0. For logarithmic function conditions are different. Okay? For logarithmic function, base should not be equal to 0, but base should be greater than 0, any positive real number. Okay? Input domain should be only positive real numbers you are going to give. This is condition for logarithmic function. Okay? We will see the graph of logarithmic function, then we can understand easily. See what I am writing. Where it is coming? You see 1. This is 0. If you give input between 0 and 1, 0 and 1. See, always positive number means 0, greater than 0 only you can give. Greater than 0 if you give up to 1, the value will be negative. Y. Y is output. Range. Range will be negative. But if you give greater than 1 input, the range will be positive. Output will be positive. This you have to understand. Okay, for logarithmic function also, domain and range you have told. Okay. Now I want to say logarithmic function is a mirror image of exponential function. You see here, exponential function will be like this. Both are mirror images. Logarithmic function, exponential function. Both are mirror images. Exponential function is not going to touch x-axis. Logarithmic function is not going to touch y-axis. Nearest to y it goes but never touch. Nearest to x it goes but never touch. It is also increasing. It is also increasing tremendously. Okay. For exponential function, even you can do input domain negative number, positive number. But here exponential function condition is base should be greater than 1. Here condition is base should not be equal to 1. But here input only you have to give positive real number. Here range is only positive number, exponential function. But for logarithmic function, range is positive and negative both. real numbers. For logarithmic function, where range is negative, between 0 and 1 range is negative. Okay, like this you have to understand. Okay, now see, two terms we have already seen, 10 and e. What is this? Then you see log x to the base e, log x to the base 10. Log x to the base 10, if it comes, we will call it as common logarithm. If y is equal to log x to the base 10, that is called common logarithm. If y is equal to log x to the base e, we will call it as natural logarithmic function. Log x to the base 10 is called common logarithmic function. Log x to the base e is called natural logarithmic function. Okay, these terms also you have to understand. Okay, we will see some properties. Base change, some property we will see afterwards. Base change we will see, then again we will write derivative. Okay, first we will see properties, then we will go for base change. Properties. See, first of all, these logarithms are there for multiplication and division only, not for addition and subtraction. Why? Because any bigger number also you can add and subtract. For multiplication of bigger number, division of bigger number is difficult. That is why you can utilize these for multiplication and division of bigger numbers. Okay, you see what I am writing. Log of m into n is equal to log m plus log n. This is one property. That means m into n is there, but log you can keep outside. Log of m into n is equal to log m plus log n. Okay, this is one property. Another property, log of m divided by n, division. Log m minus log n. See, for n only minus is come. Division, denominator. Denominator to be subtracted from numerator. Like you have to think. Okay. Here anything you can do. Why? Because m into n into m both are same. Log m plus n, log n plus log m both are same. But here not like the case. Here log of m divided by n is equal to log m minus log n. Like that only you have to take. Okay. Now another function, another one property, log m to the power of n is equal to n log m. This is not like this one. Keep in your mind. This both are different. Or we can say log x square is equal to 2 log x. Log x whole square is not having any property. Okay. Log m to the power of n is equal to n log m. Okay. These three properties you have to note down. Then we will go for base change method. But before just base change method, one thing I want to tell. What is log e to the base e? 1. Log 4 to the base 4, 1. Log 10 to the base 10, 1. Okay. Log e to the base e is equal to 1. Like that you remember. Why? Because you see here, what we are writing, log 8 to the base 2 is equal to 3. That means 2 power 3 is equal to 8. 4 power 1 is equal to 4. E power 1 is equal to e. 10 power 1 is equal to 10. 2 power 3 is equal to 8. Log 4 power 4 is equal to 64. 4 power 4, 16, 4 cube. Okay. 4, 4, 16, 16, 4 that 64. Log 4 power cube is equal to 64. Log 64 to the base 4 is equal to 3. Why? Because 4 cube is 64. 4 fourths are 16, 16 fourths are 64. That means what you are doing, base power value. Base power value. If this power they have not given also, you can find same comes means automatically this is one line. Okay, that is one property. Okay, now we will go for base change. Let us understand base change. Base change. Base change, two types are there. Two types we can change the base. You see what I am writing? See, we are having log A to the base B. Okay, this you can change like this. 1 divided by log B to the base A. You see this B and A, if you interchange, automatically 1 divided by something you have to write. Understand now? This is one way. Another way is also is there. You see, second way, base change. Say log P to the base A is there. Log P to the base A. But you want to change log P to the base B. Here you see A changed, base okay come, but A changed. But here P you don't want to change. You want to keep like this only. But you have to divide. Log A to the base B. That means what you have to understand, you see, log A to the base, log P to the base A is there, but you want log P to the base B. Log P to the base B you can take, but it should be divided by log A. Here base is going to come. Value like to the base B. Whatever the base you have taken numerator, the same base you have to take here denominator also. Log B to the base B divided by log A to the base B. If you write, then you have changed like. You have changed like. That means what you are going to do? This you want to mean you are going to multiply this like that. See, actually you are having this. You want this. Either you divide or you multiply. Yes, I will write like this only. But what you are going to do? Old one you have to write. Again, multiplication what you have to do? Log A to the base B. You have to multiply. If you multiply automatically, this is going to come. Okay. So normally why they will write like this means bases same are there. Like this they will write. But this is required one. This is already given. You have converted. Afterwards you can multiply. Like this. Okay. Log A to the base B. Okay. Now let us go back again. The derivatives. Why? Because we need not what we can say prove those, but again we will write d by dx of e power x is equal to e power x. Exponential function. Already I have told a is 2.71828. Okay. Okay. Now another one, d by dx of log x is equal to 1 by x. See, I have not written anything means base e. I have already told. Or else I can write base. Okay. Base should not be equal to 1 and base should be greater than 0 for logarithmic function. But here base should be at least greater than 1. E is 2.7, already greater than 1. Okay. Logarithmic function conditions also I have told, domain I have told, range I have told, both graph I have done. Okay, all I have done. These two without proof you can apply. With these two formulae only we are going to write. We are going to do the exercise 5.4. Total 10 questions are there. Okay. Now I think we have understood very clearly what is exponential function, what is logarithmic function. Okay. With the graph also have understood. Tremendous change is going to come in range with small change in input. That is why those are going to covered as exponential function. Okay. Let us stop this class. We will close. We will meet next class with 5.4 exercise. Okay. Thank you very much.